Hello everyone, this is Mainak and you're watching Civil.Pro, and today what we're going to do is we're going to make a steel structure tutorial in the Tekla Structural Designer software. So it's been a long time I've made a tutorial in Tekla Structural Designer software, and the uniqueness about this will be I'm going to try response spectrum method for designing the steel structure that will be an industrial truss mainly, and this will be in Seismic zone 5. So let's go ahead with the procedure, and if you guys have any comments, any suggestions, any corrections which I need to make sure to reach out to me in the comment section. I make sure if I can, I answer those questions. Okay, so having done that, let's click on new file, and again make sure to like the video that because that really appreciates and enhances my reach to the audience. Okay, so click on new file. You will have a new file ready here, and we first of all go to model and we go to construction levels here. So we'll put a level below, and I always prefer to take the plinth level as 0. There are many reasons why I tend to do this, because when the structure takes the structure height in various software, because I use multiple softwares, then they usually calculate the structure height from 0. So the structure height calculation is essential for the seismic load and also the wind load. That's why I always keep the base as, or the plinth level as 0. So the foundation level, you can just put the level here minus 1.5. You can just put it here, and this let's treat this as the plinth level, and let's insert a level above this, and we can call this TOS, or top of steel. There will be no slab if you call this TOS. If you call this SSL, then there will be a provision of assigning the slabs. So here basically here we are going to go with a spacing of, let's say, 4 meters. Okay, so automatically this goes, you don't need to touch the levels as except for the foundation level. You give this 4 meters, and if you want the apex here as let's insert the apex, which is the topmost portion of the truss top chord. Let it be 1.2 meters, so it will be 1.2. so automatically if you click, that will be 5.2. so this is the apex, and this is the truss starting point here. And we will prepare the truss, we'll prepare the industrial truss here, and we'll also give some bracings here. So that's the idea here. So these levels are created. We'll go straight into the plinth level. So plinth level is already there, it's a structure base. If your plinth level you're making is different, you can go to the structure window, open the levels icon, and then click on this base or whatever your plinth level you're mentioning here. So we start planning at the plinth level here. So you can just customize according to your default grid. I'm just going to go create a rectangular grid, but if you have a default grid, you can create the default grid here. And comment below if you want to create just to watch a video using a default grid, or you can even send me some dimensions. I can do that. Okay, so next here. So in the x direction, number of grids here. So here you can see, you can easily understand what is the x direction. So this is the x direction, and this is the y direction here. So the x and y are the two lateral directions here, like in ETABS, like in AutoCAD, but in STAAD it is different. You can see x and z here in STAAD. So yeah, the count here, you can keep it to 2. We can keep it the count to 2, and length here, it is 6 meters each. So from here to here it is 6 meters, from here to here it is 6 meters. So let's do 5 here, 5 meters length here. And you can this now grid, this doesn't really matter here. And here also you can see this count is 6, and length is 4 meters. So we're just going to keep it this way, and next, and then finish. So this is our grid which is ready here. And first of all, we're going to create some columns here. So make sure in the model, the settings in the home, you have these settings here. Settings are as per your country, whichever country you are designing, that should be set to from in here also and in here also, because these are the loading parts which you are taking into consideration here. So that's why it's important. Then we go to model, and we just select the straight away on the steel columns. Okay, so now let's create a steel column. First, you can see a default steel column has been selected here. So here we have to select the grade of steel, grade of structural steel which we are going to work on. So I'm going to select FE 290. Okay, you can select the grade of structural steel which is available here. and then you can just do this. And if you want to select the section here, and you can just select the among the sections here. So you have ISSC, ISLV, ISMB, so various sections you'll find available here. Okay, so we're going to go with the rectangular hollow sections. You can go, okay, any kind of section which you want to give. I'm just going to use this rectangular hollow sections for the columns. And before doing that, I'm going to just define the topmost level here as the level which is below the truss apex. Okay, so just select this like this, and you can see this in the 3D view, the columns which are ready here. So after the columns are done, I'm going to go to the front view here and select the supports like this. You can select in other ways also. Just right click on your mouse and rotate this like this to see this. So I'm going to just do everything as fixed here, to just assign these supports as fixed supports. So the supports are fixed, and my columns are defined. Now I need the truss, and I need to prepare the truss amount here. So there are many ways to do this, but one way is to use this option of truss here. So the type of, but the limitation is that the type of truss which you select should be according to a particular floor here. So I'm going to select this bowstring truss here, and you have to select the start point and the end point. Start point and the end point. Well and good. And click on next here, and next. Now this height is 1.2, the height of the bowstring truss. And panel division, if you want to just increase, suppose I increase it 10, it will be 10 here. So if you keep it 5, it will be 5 here. So you can keep this accordingly. The panel distribution here, let's go 6. Yeah, 6 is better because you can see the main chord, the main chord is hitting there. So 6 gives uniformity here. So just click on finish here. 6 gives the uniformity. So we have a truss here, and I'm just going to validate for checking whether this has a problem with the member intersection or not. So you can see we have a problem with the member intersection here in this place. So if we do this, then let's check, then there is no problem as of such. So we have to do this in all the members here which we copy. Okay, so let's do go to edit and go to copy, and we can copy this like this, like this, like this, like this, like this, and like this. And we already know this will have some problems, so control and select this will have some problems of members selection. And because I'm just considering practicality, in practicality with large structure you will not be able to do this in each and everything. So let me delete this, because this will be helpful if you want to design the larger structure here. And copy, and we'll just select this point and paste them the center part, central column in all. So then we'll validate, because the member intersection problem is real, so we have to deal with this in the earlier part here. And in the truss also you have the option of changing the type of truss which you are going with. Okay, so this is SHS, square hollow section, which has been used of 150 mm. And here in truss you find that the various members have various sections also, those truss are also. But in the predefined version you cannot change in each, like you cannot change the bottom chord and top chord and internal members separately. You have to give one single section for all. So that's it. So I'm cool with this circular section, but the grade of steel I should maintain the same grade of steel for all. So that's why. And maybe we can go with a lower size section also for this 150, and instead of 150 let's try to go with 125. And yeah, so I can select all the truss and do that. and just change the grade, and I'll try to go with 125. If it passes, then it's good. If it doesn't, then we'll just change this. So again, I've selected 125, this for the truss. So obviously we have to do something higher than this in the column itself. So in this let's go with square columns only. Square columns, let's go 150 for the columns. So this is giving higher size, strong column sweeping behavior. This is giving higher size here. And now it's time for the purlins. Okay, validate just for the checking. Now it's time for the purlins. So let's connect the purlins here. So for the purlins, let's define the beam here as the purlin here. So here let's go FE 290 is fine, and the section here, section for the purlins, we can go with same type of sections as well. This square hollow sections, you can go for the purlins as well. So let's go 30. It will be let's go to 25, like it will be 1 inch into 1 inch per purlin. So this will be very suitable here. Let's we can also do this while doing the purlin here. We can do one side and then we can just do the other side, mirror the other side definitely. So what I'm going to do, because I'm going to get the grid points at a specified point here, so I'm going to just provide the policy, like I can provide a purlin in between as well, that depends. So I'm just going to try to make the structure as light as possible, along with the safety, the economy also. And if it doesn't pass, then we're going to just go with the higher size, hopefully. So you can do, just for showing you, I'm just showing you this. If you want to insert a purlin in the center, this is not that you cannot do. So you suppose you have the this they apply one at the center, the middle one is the center of this, the middle one. Okay, so like this you can do. So I'm just showing you, let's do this. Okay, so we can do this like this also. So practically also this intensity of the purlins, which we are providing here, I think this is the practical intensity at which purlins will be provided. I could have just provided at the intersection, but practically this number of purlins will be required, because generally in industrial trusses now PPGL sheets are used. You can Google PPGL Tata sheet or SRMB sheet. You can find those, just for viewing those. Okay. You can see those kinds of sheets will be used, or I will Google and show you the kind of sheets which will be used. So now I think I can kind of I can go with the mirror option here. What's the easy way to do this? I think I can select this and deselect the central one. So obviously, because otherwise this will be overlapped. Central one first, and then I can select this as, okay, let's see, steel beam rolled items here, 36. These are beams, right? Beam rolled items. I hope so. These are beam rolled items over here. Okay, FE 290 25, yeah, these are beam rolled items. So I can mirror this. So I edit and I'll go to mirror and pick points here. Oh, entire thing is coming. Oh, I think this didn't work. Let me validate. Okay, it's okay. Okay, let me just try to do it again. do it in different way, I guess. I think if I do this, go to this view side, press with the help of control, if I select this, that would be much simpler, right? Yeah, that's a better way to do this. We do and we learn to better way to model, because I think top view will be good view to do the mirror. Go to mirror. Oh, that didn't work. I'll just mirror again. How it will work? Yeah, that works. Yeah, right. Yes, absolutely. Validate to check. Validate says sir, I'm fine. So we are fine as well. Okay. So now I think we model is validated, and one thing which is missing in the model is the roof. So we'll go to model, and here we should have the option of you can see flat slab, you can see uh, okay, yeah, roof panel. Yeah, we have the roof panel here, roof panel, roof type, flat, monolithic, default, duo pitch, hip main, include in diaphragm. No, we don't want to include in diaphragm, we just want to do this for the wind load and probably to assign some loads as well. But I think we have to do this, or can we do this? Like, this will save a lot of time, but I don't know whether which is the right method for the analysis. Okay, let's go with this. So what we want to do is select this, click this, and then click this, click this. You can double click here, then it's fine. So better I just show you this double click method, or there is another method also. Select here, and then select here. So there are two methods to do this. I prefer the double click option better. Okay, since it saves some time, you can say. Okay, so yeah, did I reach the center already? No, I have one more remaining. Yeah, done. So yeah, half items are done. I think I'll just go to the top view here and use the mirror option. I click on escape to just escape this, and control and select this, and this, and we'll use the mirror option here. Go to model, and we'll use the mirror option. Oh, not model, we have the option in where did you have this? In edit. Yeah, I forgot almost. Select this, and no, this will not work. Cancel and mirror. Will this work? No, this will also not work. Cancel. This is not working, this is not working. Will this work? Yeah, this is working, right? Yeah, this is working. So cool. Just validate, and then we go to home. Actually, we just select this here and move around. Yeah, I think we are good. We have assigned the slabs, we have assigned the this thing. So now let's assign the loads on the roof panel. So dead load, let's assign. I'll first assign and then I'll show you in code, otherwise it will be a little bit boring. Dead load I want to assign, and I want to assign level load, or yeah, area load, or even level load. I think I can do area level. Okay, let's go to area. Area load of in dead load we'll do 0.33. okay, load we'll do here. And what happens if I click on level? No, level load won't work here. We have to do area load here. 0.33. Why 0.33? How 0.33? We'll just show you. Okay, don't worry about that. And obviously in all conditions it will not be 0.33. it will vary, it will depend and all. So you just have to get accustomed with the code to do that. And in live load, that is imposed load, will take area load of 0.75. Why 0.75? Why not something else? We'll also show you. And if you have different material, how to do this, we'll also show you. Don't worry, just assign this for now, and then we'll see what's up. Okay, no problems. Is any particular part missing? Yeah, this is what's missing. By the way, I'm not sure whether I should have assigned this like this. Maybe there is an option to divide this or split this. I don't know. So yeah, I have to figure that out. That particular part, whether you should have assigned this separately. Okay. Let's go in the Codal Provisions here. So for the live loads, you have to look into the table number 2 of IS 875 part 2 for the Indian codes. So you have the flat roof, slope or curved roof. This imports loads on various types of roof. Okay, so you have sloping greater than 10 degrees, sloping less than 10 degrees. So you can measure the angle and then you can see. So flat roofs up to 10 degrees, you have the access not provided. Obviously access will not be provided here. Access provided means somebody will not do any activity here except for maintenance. Obviously maintenance, except for maintenance purpose it is okay. Then will be 0.75 kilonewton per meter square. So that's why I applied 0.75 kilonewton per meter square. Otherwise you have to use this formula. Minimum it is 0.4 or maximum it comes around 0.75 only, because maximum it will 0.75 obviously, because maximum is 0.75. So if you don't want to, if you are lazy like me, if you don't want to measure, you can just simply go 0.75. It will be on the safer side every time. Okay. Okay, slope greater than 10 degrees, you will have for roof members or sheets or purlins 0.75 kilonewton per meter square, less 0.02 for every increase in the 10 degree slope. So for every increase in the every degree increase in the 10 degree slope, so you will have to deduct 0.02 from 0.75. so if you want to measure, then it's okay, or otherwise it's accepted that if you apply 0.75 live load, then it's okay. So this is about live load part. So what does the dead load part say? So first of all, for the dead load part, you have to select the material. So in this project, we are using this PPGL sheet. So this PPGI is mainly zinc coated. PPGL has aluminum, zinc and other materials, silicon also, some silicon also. You can see this, that's why it is used. So it's better, it's stronger, it's lighter, so everything, it's better than PPGI in my opinion, humble opinion. So this is a sheet which you are going to be using, and this is a sheet which will also be used in maximum of the roof truss. You can use DSW and Tata. These are the so-called good companies here available, and so these are trusted companies, so you can use those sheets, and those sheets will have some load, and let's see what are the Codal provisions say about these things. So for that, if you just look into the our IS 875 part 1, which is the code for the dead load, in 43 we'll find sheeting. So now PPGL is not updated, but we have asbestos and galvanized iron, which is the PPGI sheet. So this is the closest we can find, and you have to look under section 39 here. So let's go to section 39. So in section 39 we find that we have metal sheeting, protected galvanized steel sheets, and plain and corrugated. Now let's look at the dead load here first without reading further details. So kilonewton per meter cube. So you have 4 classes. So what the maximum? Maximum is 0.131. So 0.131 is literally the maximum in the sheets, and you have this nominal thickness of the sheet. So if you know the thickness of the sheet, how much mm, then it's good. Like if you know that generally the sheet thickness is 0.63 or up to 0.863, then the maximum we can go is 0.54, 0.53, 0.52. So just knowing the sheet thickness, you can go, or if you want to go into details, you have this IS 277 2003, which you have mentioned here. This 1985 is updated to 2003 now. So there's 4 grades of steel depending on the depth of corrugation and the pitch of corrugation. So but if you don't want to go into this that much detail, what we can do is just we can know what are the thickness of the sheet which will be used here. Generally it is 0.63. So in our case this is 0.63. So if I give a load of, let's say, 0.06, then it should be maximum. So what I'm taking 0.33 kilonewton per meter cube, just to accommodate the unit weight, and just a bit of factor of safety as well. So 0.33 is more than enough for the accommodating the self weight of the sheet as well as some extra factor of safety. So 0.33 is way on the safer side, which we have provided here in the dead load part, this one. So just click here, this is what we provided here. This is not this one, just click on the load here. This is 0.33. So 0.33 is more than enough. If you want to go more on the economical side, you can just, I think, provide 0.2, or even for maximum, what is it, 0.2 or 0.15 should be maximum. So that's what you should have put as per code. So we're rocking with 0.33 here, and this is a dead load and the live load. This is pretty much the loads which will be available here. And in this kinds of industrial trusses, mainly the in despite the location of this being in seismic zone 5, the main factor here which affects this is the wind load. In majority of the cases, sometimes the seismic load can also be there, don't get me wrong, but the wind load consideration is a very important part here. And for that we need to analyze the wind load here also. So here we go to model, and then we have the wall panels. So we apply the wall panels here, select this, double click on this, right click outside. Okay, did I mess up? No, I think I select, oh, I should have clicked like this, Ctrl+Z. Sorry, I should just messed up here. Wall panel, select this and select this corner, that's it. Select this and select this corner, that's it. Rotate this, select this and select this corner, so that's it. Select this and select this corner, that's it. So these are the wall panels which has been applied. And yeah, obviously this wall panel has been applied for the wind load application purpose. Validate once again, and then we go to load. So basically dead load and live load has been defined. If you want to define the seismic load and the wind load that's remaining pending, seismic wizard, and let's define the seismic load first. Obviously the code spectra will be used, and ignore seismic below the plinth level. And our seismic zone in zone 5. Site class, these are the rock types, so we'll go rock with medium soil. Importance factor is 1. And general, this is the zone factor which you will find in table number 8 if I'm not wrong, and of the ISO 1890-2016. So we're going to go with response spectrum analysis here. No plan irregularities here. I can use orthogonal combinations here. Okay, so you model response spectrum analysis permitted, orthogonal combinations is permitted here. Clause 6.3.3.2, check that out of the clause. If your building lies in seismic zone 4 and 5, then compulsorily you have to go with this orthogonal load combinations. Next here, and we have this RC moment resting. We have this steel moment resting frame without any masonry in place. We will use masonry here, so we cannot go with this because in this as a filler material, masonry will be used. So yeah, we have to go with this. Speaking of that, I just give the plinth beam. I should have applied the plinth beam. So yeah, we need to apply the plinth beam as well. I think we should have done this before assigning the seismic load. So let's go to base, and let's go to model, and let's select the beams here. So I've just gone with all normal members here, FE 290, and yeah, MB 350 is too much overkill. I think we can go with MB 300. No, this is MC, not MB. Go above for the MB sections. Medium beam, sail, even 250 is okay. Yep, sail MB 250. This is for beams, and obviously you have to apply some dead load, right? So yeah, what is the floor to floor height again? I think the floor to floor height here, which we had applied here, measure, it will be around 4 meters. So 4 meters here. Just open the calci. 4 into like 10-inch walls if you consider 0.25, that is 250 mm, into unit weight of this brick and plaster together approximately. Okay, I just messed up. 4 into 20 into 0.25, enter, it is 20. So we'll apply 20 here of this is the dead load will be around this perimeter only. Okay, so load and dead load here, full UDL here, and this will be 20. So I cannot apply any shortcut here, so we have to click each and everything. I guess if there is a shortcut, I discovered this, I will be really helpful is the word. Okay. Now I think I can go for the seismic load, which I really love. I love the seismic load. I don't know why. So seismic load, seismic wizard, next, and this is the plinth level, and this is the zone 5, and this is the 1 here, 1, and then click on next, and then we'll use model response spectrum, and we'll use the orthogonal load combinations here, and then we'll use this building type here, and we'll building your type. We cannot use this RC steel composite frames, we cannot use steel masonry frame, this also, so we'll have to use this because this is the only option here which is left. Okay, fundamental time period will let the program calculate this, and moment frame system, obviously moment frame system. RC building is not available, so we'll go with steel building with SMRF. Okay, steel buildings with SMRF here, and obviously we'll find that while import load taking a factor of 0.25, obviously we need to do this. Applied mass in z direction, this we cannot take here, and yeah, storage drift, yeah, we want to include the storage drift here. Click on finish here, and we're going to create some load combination as per the seismic load here. Okay, and then we just going to go to the wind wizard here. Now for the wind wizard, we'll just go to load here, and we'll go to the wind wizard. So obviously the directions are there, and next you have this worst case data which is available, and orientation go 90, and if 90 doesn't work, go with 0, so this doesn't really matter that much. Basic wind speed for this current location is 55. You can find in 875 part 3 in the annexure you can find, and also there is a map where you can find the basic wind speed here, probability factor, and K2 and K3 factors also you can find. Also, if you just follow my channel, I have a document which I have just modified, and I've shared with you a lot of times. In the previous video to this also you'll find this video, this thing. You can just for the reference of the code IS 875 2015, which is the current code, the date of recording. So then the building width and all they calculate automatically here. K1 K2 factor we will take as 1 here now, otherwise you can calculate. Next, and then fetch distance we're going to give this 5, and the terrain category 1, it means the maximum wind load, so we'll take the 1 because generally industrial structures are in located in open terrain locations. So if you want to give a feature here, and then it's okay. This is basically another factor which they are trying to calculate here. So this is the final calculation here. You can finish. So this calculation part is really pretty simple here, the basic. Then you have to add the CPE and CPI values. So these values, you can, this really depends, and there is a process to calculate that, but just if you just check the this particular reference, you can just check the reference here in the windward side and leeward side, everything we can calculate, and then we can apply this. But if you just I'll just go a little bit on the safer side, and we'll go with 1 because generally it is never more than 1, so we keep the directions same, and we'll just apply 1 here. Okay, so we'll be on the safer side, and we'll also save some of the calculation time which is required to do that, because that really takes some amount of time. But if you want to go a little bit on the economical side, on the precise side, I recommend that you calculate that, right? So we'll go to load combinations once again, because we have to define the load combination. You see, these are the load combinations which are in fact created. Now we click on generate the load combinations, the operating load combinations here, which will be generated here, and yeah, obviously this load combinations also. Okay, and then next, and yeah, notional, this we don't want, and you can see these are the load combinations which have been created here, and then click on OK, done and dusted here, and then we just check our model, and yeah, wind model has a problem, and a roof CPE. So monopitch roof CPE scope is beyond this. So basically what is trying that either okay, what action they are recommending to take here, they are also either review the roof panel geometry or apply the wind loads, either roof geometry and modify it, either review the roof panel geometry and modify it or apply the wind load manually. So they're asking to apply the wind load manually to the roof, or either you can modify the geometry. So I don't think this will create any problems, but I think we should solve this because you guys will also have the problem. So let's try to solve this. So go to load and go to load cases here, and yeah, we have everything here. We'll just add a new load here, and this will be our W, just capital C please, WL, and let's see if we can just take the wind load into consideration here, and then click on OK. So then we just select the wind load here, and all the available options are available suddenly. So we can go to scene content, and just for the ease, we can remove some things. Walls, no. Portal frames, trusses, yeah, this helps. Trusses have been removed. Yeah, I think that should do. Let's go, and if you did remove more than it is, and then we'll select this. So let's go here in the wind load part. In this portion, wind load is there. Okay, let's ignore this for now. I think this I hope that we could assign the CP like this, but I think there is no option. So let's see if we can design this with this. So first of all, we'll go to design and go design all static. Then after making this pass, then we'll go with design all as RSA, and then we'll hopefully be able to solve some of the errors if possible. So we have this. So this is our result which we have obtained. So there are some members which have some wording. Majority members seems to have passed, and this particular location, this seems to you have this. Okay, this is the base plate, so this is beyond design scope. This is okay, but the members have passed, and let's see what is the passing member size here. You can see you can also generate drawing for this particular member. Let's see. Yeah, let the AutoCAD open, and we'll check the drawing for this member as well. But the member is designed, but we have some checks in which this is these members are failing. So we have the drift. Yeah, these are the warnings here. Okay, so what this is okay, but in the solver model, but we have the drift check. So it is failing the wind drift checks. So yeah, we have to take care of that because it cannot fail in the wind drift check. So basically, to improve the that visibility, yeah, let's see the file here. Yeah, we have the section SC150 for the columns here. So improve the visibility. I think the stability, we can add bracings to just improve the strength of the structure here. I don't know that will make a difference or not. Let's try. Otherwise, we'll skip that that part. So let's go to X brace here, and let's say material of the brace, hollow section 80H. It's okay. It's fine. Oh, just X brace. Select this, and yeah, that's the right way to assign this. So select this, and double click on this. That's the way to assign this X brace. So I think I will copy this X brace here, model, and go to edit. Okay, copy, and then so there will be obviously masonry here, but this bracings, I think there will be in addition to the masonry. I hope that improves the stability of the structure, but let's just check. We don't know yet whether this will be any difference or not. So let's go to load here, or design, and design all RSA. This time we'll just go RSA directly. Let's see the results. So this is the result of the seismic analysis. So we have some of the purlins in the beyond scope category. So basically, because the wind drift you will not find here, because response spectrum is mainly for checking the your earthquake loads, so the wind loads will not find, but we have some warnings beyond scope in the Parins, means that this particular section which they've used, this section doesn't actually make the it doesn't pass actually. So yeah, we can try to just change all the purlins here, because why not, let's just try to just change the purlin type to something little bit higher. We can go with circular, I guess circular sections, or if you're preferring welding here from the practical point of view, I think circular shouldn't be preferred. Box or even an angle section should be preferred. So let's try. So here we have the design section, let's skip that. Design section ISMB. Design section is important because it ultimately designs into this. Okay, let's go ISA. Can we go ISA? Angle section, rectangular hollow sections here, RHS or SHS, square hollow, rectangular hollow, doesn't matter. Let's go square hollow sections, and then let's go here. Let's change this to let's select a square hollow section here, square hollow section, and let's see maximum section 180. Let's see, let's select this, and now let's and right click, and then a design selection RSA, that should be a design selection RSA. Let's there should be option. So let's see what is the result. So let's check here. Yeah, so the members have passed. So our member is now safe here, and also this members, middle members, have some warnings. So let's check the warnings here. Here design member, not static, sorry, we have to go RSA here, design member RSA. So here design node and okay, lateral restraint, I think this is okay, this is a modeling problem. So yeah, I'm okay with this I guess. Yeah, so here this one we'll select this, and let's select the members also. Here let's go for steel, okay, non-composite steel, ISSC. Let's go with ISMB here. Select ISMB, and let's select the ISMB section here. Section, let's select here, new edit. So we'll select ISMB here, ISMB let's go 400, select ISMB 400 here, sections, ISMB sections, and then right click them, and design selection RSA. Let's see the results here. So yeah, still we have a warning, but the important part has been at rest here. Let's also go to review here and go to the ratio here to check here this things. So we don't have anything in red here, so this should do. There are some beyond scope members as well. So, and also the thing is we have the if the member is failing in seismic drift, so we have to figure out a way to just to reduce the seismic drift here also. So that thing is done. So that being said, the design is not perfect here, but majorly you have an idea about the steel structure design. And if you have any comments, any suggestions, and if you find any way to do this better without any warnings to solve the seismic drift error, let me know in the comments. And thank you for watching. Bye bye.